Hello. Right, so I have these files here. Is a link for the file I'm going to edit. Alright, so yeah, you can go to this and download it. And there's a few examples you can just go through like this. So you have Vim on your computer, you can open this using Vim, and you just go through this kind of tutorial and see how the command can be used, apply into coding. So we're just gonna start in like five minutes. So yeah. Right, so the link is also pasted on the live chat, so just click there and download it. Alright, let's start with the basic navigation. So you can see here, right, in Vim you can either use the arrow key or you use the four buttons H, J, K and L for navigation of the cursor. So over here you can see K is to go up, H is to go to the left, L is to go to the right, and J is to go down. So I would generally advise you to get used to the H, K, J, K, L is because your hands will always be on the main keyboard. So when you type the code and you do the navigation, your right hand doesn't have to move around too much. If you use the arrow key, you have to lift up your right hand and go all the way to the arrow key, do the navigation, then get back to the keyboard to type something. So to me, if you can use the HJKL for navigation, it will be much faster when you get used to it. So now let's go down, right? Move the cursor around the screen until you are comfortable. So maybe spend a few more minutes. Try to go around with the H, K, L and J to go up, down, left and right. The thing is, you can move this using the normal mode, which if you're not sure what mode you are in, just press escape button and then you are in normal mode, and then you can just do the navigation, right? So you can see if I press hash, yeah, go to left, right, up, down. You get comfortable with it. Right now, okay, using the down key, move to line 15. So, so above is just a basic navigation, which means the arrow. If you really want to get used into this kind of practice, you may want to disable the arrow key. The details of disable I probably post it later, but yeah, just in case. Yeah. Alright, let's go to the advanced navigation. To efficiently move to some point in the file, use a number plus navigation. So in Vim, every command, even the navigation H, J, K and L's are called command moving, and any of the command keys can be repeated by putting a number before that. For example, let's say if you want to move down 5 lines, right, you can either press J 5 times, 1 2 3 4 5, or alternatively you can just press 5 and J. It will do the same things but with fewer keystrokes. Right, let's see, move to the right 44 times. Right, this is a lot of numbers, so you will see the effect. Otherwise you have to go all the way like this. It's take quite some times. Let's say with 3 keystrokes you can go to this. Following? Right, move up 2 times, so similarly 2K, you go up 2 lines, and move to the left 2 times, just 2 and H. So now you can see that you can use the number for faster going. Right, now the next move we're gonna make is, sometimes you may want to jump to the top of the files. For example, you want to include a new files, or you include a new library when you do the coding. For example, when you do a problem and you want to include the math head, so just go GG, just type GG, will bring you all the way back up to the top of the file. So you see my cursor now is at the top of the file. Right, this is quite useful when you just want to jump all the way up to the files. And then now go to the line. Oh, there's a typo here. So if you want to go to a certain line, you can press the number and then press capital G, which is Shift G. That way you can go directly to the line. So if you see the line number on the left hand side, for example, now if I want to go to the line 27, I press 27 and then capital G. Now you see my cursor is now on the line 27. Alright, any difficulty so far following, or are you really following? Alright, anyway, you can rewatch this if you are not following, and maybe you do work along. Right, so let's move to the last line of the file by entering. Yep, you can go to the last line of the file by press capital G, and then maybe you want to jump back to 29, which you can use the 29 capital G to bring it back to the line. So I do it again, G. Now you see my cursor is at the last line of the file, and now I want to jump to the line 29. I just press 29 and go to that line. Alright, or alternately, if your files is long enough and you want to go one full page down, but imagine it's similar to pressing the page down button when you in a Word document or something. Yeah, so this is similar. You can press Ctrl F, which will bring it to the next page like this, and Ctrl B for going back. Right, you can try that. Right, or even if you want to just scroll one line down, you can press Ctrl E. So you see it's the opposite of Ctrl E is Ctrl Y. And the same thing, because this one Ctrl E is a command, you can put a number there so that it will repeat the command, like how many times that you put. For example, you want to scroll down 10 times, you can press 10 and then Ctrl E, that will scroll down 10 times, like so. Alright, let's go to advanced navigation 2. Right, so you see jumping back and forth between the lines may be good, but you might not be sure of how to apply it when you do your coding. So here is a very simple example that I put so that you can see the power of it. Well, ultimately, yes, you can go like scroll all the way up and down manually, but there's a faster way of doing it. So why not try the faster way? For example, like fix the typo on line 62 and follow the next. So I don't know what's the typo is, so I just go to the line 62 by 62 and capital G. Now, alright, so here's a return statement, but there's a typo, so just gonna put there, right? And now you realize that on line 55 there's a typo there as well. You see the magic number, so instead of magic number is magic number. So you wanna go to that line 7 times. So to go up, you can use key K, so 7 times K is 7K, and now you are at line 55. Alternatively, you can just use 55 and then capital G. Yeah, it's all up to you. And you change that. Right, fix the typo. Now add a function prototype in calculate magic in before main. So now you see the main is at line 43. Now you want to go to line that and insert that function prototype. What you can do is that you go to line 43 by 43 and then capital G. Alright, to insert a line before that, probably you have already know, you can press Shift O. That would insert a line above the line that the cursor currently in. So yep, now you can just put the function prototype like so. Right, so you can see if you combine all these steps together, you just jump down all the way, jump to the middle of the file, and then jump back up to the top. Imagine if this one is a new file, then yep, you get what I mean. So the point is that instead of you have to go all the way down here, do the correction, scroll up, do the correction, then scroll all the way up and do this correction. Yeah, you can just simply jump to this line, fix it, go 7K so that you don't have to hold the key, and then go before the main. Similarly concept. Yeah, similar concept. Right, great. So that's about navigating between the lines. Now let's go next. Right, but sometimes moving across a line is not what you want. Well, moving between the words on one line, usually that's what you want to go. So just now what we've been talking about is going up and down. How about go sideways, left and right? Right, before we move to that, there's 2 definitions you may want to take a look at. The first one is a word with lowercase, right? By definition of inside the Vim, or you can see all the cheat sheet online, they say a word is like without the punctuation. So what it means is that this one is one word, this one is one word, but this one, the word with a dot accompanying it, you might think it's a word, but actually it's two words. So to go one word forward, you can press W, just the lower W, and it just jump word to words. So you see the alphanumeric is actually three words. So the first one is alpha, the second one is the hyphen, the third one is the numeric. So 3. Yep, you can see the example here. So word 1, 2, 3 is one word. When you press W, just jump forward one word, and the cursor will be at the beginning of the next word. Right. Similarly, so now guess what? If I press a W, the cursor will be on the comma and not the but, the B of the but. Similarly, yeah. So you get the concept. So now we have another definition which is word but all capitalized. This one you can use the capital W, where you can press Shift and W to do that. So you see now, if the word doesn't have the punctuation inside it, the effect is very similar to the above one. But if, for example, if E dot G dot, if we use the normal W, it will have 4 words in it. So right. But if we use a capital W, it would just jump to the W of the words dot words. As so, right? So like this. Yep. So if in this case the cursor, if I press Shift W, would jump to the S of the something. Yeah, even though it's typed wrongly, but yep, you get the point. Right. So here is the whole thing of it. You can try it. So to go backward with a similar effect, you can use B. So the opposite of the normal W is the normal B, and the opposite of the capital W is the capital B. Alright. And we have another navigation as well, which is E. E, we just go to the end of the word. If it's a normal E, the lowercase e, it will just go to the end of the current word, which is the cursor is on. For example, yes, in this case, go to D, as you can see, or F, E. So it will go to the end of the next word, or the current words. If the cursor is in the middle of the word, like so, it will just go to the T. Alright, and the effect of capital E, yes, you may guess, is very similar to the capital W. So in this case, it would just go to the comma and the S, right, like so. This one would just go to the full stop behind. Okay. Now go, right, let's go, stop. Right, go to the 13th word forward. So bring cursor to this word. You may want to try that. Or sometimes you may not have the time to count how many words are there, so you just press W. So where you can see is similar to the way that you use the cursor normally, but this one is a little bit faster. So yep, you may want to use it. Right, let's go next to editing. Editing, this is probably what you want to use most of the times, which is changing of the text, replacing a word, something like that. So for example, if you want to delete a single character, you can press X. So you don't have to press I and then you press backspace, which is 2 keystrokes. With pressing X, it's just 1 keystroke. So yep, it figures out. For example, if this code, if you want to fix it, well, this one you can delete this, this, and now if you want to jump to the next word, maybe press 2 and W, you bring to the next word, and just do the normal editing. Yeah. So you can see you don't have to press I then backspace then press escape so that you can navigate more. And this time you just delete during the normal mode. So you just delete and then navigate, delete and navigate. Yeah, it may save you some time. Alright, the next thing I want to talk about is the trick with the X to swap two consecutive characters. Sometimes when you do the coding, maybe there's some typo because you type too fast. Some of the character is swap position. For example, in this case I want float, but it's become this one. So what you can do is you can press XP, which will swap it. The way it does is that X will delete the things, the character that the cursor is on, and the P is just pasting the whatever is cut in the clipboard after the cursor. So in overall the effect is just like swapping the two consecutive characters. Right, moving to this number, so XP again become number. Right, not very impressive, but it's maybe useful sometime. Right, how about deleting a whole word? Right, so based on the definition above, like the normal word and the capital word, you can combine them with D. D stands for delete, and then you already use them. Sometimes when you use delete the whole line, maybe DD or D word. Right. So in this case, there's a duplicate of this one. So if I want to delete the whole word, just D and W, which will be fast. Right, and now I want to go into, so over here you can see the two integer, which is duplication, and I may not want that. You can just D and W. Right. Okay. Let's go to the next one. Well, deleting the whole line probably you already know, which is DD. So it doesn't matter where your cursor is. The moment you press DD, you will delete the whole line that the cursor is on. Right, like so. Right, let me repeat that. Now the command should be deleted. Right, DD, and that's gone. Okay. Right, how about deleting just half of the line? Like, you just want to delete not the whole line, but the thing that you want to delete is sufficiently a lot so that you may not want to just delete manually by backspace all the time. So for example, look at this statement. This is just an example of a superfluous command and you want to remove it. The way you do that is just move the cursor to the first character of the slash and then press D and the dollar sign. The dollar signs signify the end of the line. So that means you delete everything from the cursor until the end of the line. And yep, so you just delete half of the line and you keep the essential first half. How about now let's do that. How about you just want to delete everything before the cursor? This one you can use before the cursor, 0. So similarly to the dollar signs, zeros signify the beginning of the file, the beginning of the line. So for example, if your cursor is here and you want to delete everything before that, it's D0, and yep, as you can see. Right, so definitely you can try those. Right, what about delete a block of code? And this way there's two ways of doing it. Either you DD all of the lines, so just DD like so until everything is deleted, or even if you combine with a number would be a nifty way. But if sometimes you may not want to count, maybe you want to do quick one. So this one 2 4 6 8, so you want to delete 8 times, so you may press 8 and DD, which will effectively delete the whole things. Or you may want to know what you are deleting by pressing V. Will switch to a visual mode, and now you just go down and select the line, the block of code you want to delete. So here the whole block of commands are highlighted, and you can delete them by pressing D. Right, copy and paste line of code. This one may be another useful things that you want to take note is that you may want to, for example, you want to make a copy of a printf statement for like how many times. What you can do is you can yank the whole line by pressing double Y, which is stand for yanking the whole line, no matter where your cursor is. And for example, now you want to make 5 of that line, so the line is already there, so you want to make 4 of that, you can press 4P. Right, so this is nothing much. Maybe probably some of you already know this, but just some of the trick that I pick up along the way, so that it's fast, is get my coding a little bit faster. There were a few more tricks, but that one will require code so that you can see the usefulness of it. Probably I will post the other half of the tutorial so that you can download it and try it on yourself. Right, okay, I take probably five minutes before I go to solving a problem using that is related to array. let's get back. Right, so here I have a problem that is relating to array. So let's read through the question and see what he's asking. Right, Watson gives Sherlock an array of length n and asks him. Okay, I will paste the right here. Right, so you can see the link inside the live chat, which is the link to the question. So feel free to read through it. Okay, so let's go through the question again. Right, then he asks him to determine if there exists an element in the array such that the sum of all the elements on the left of it is equal to the sum of all the elements on the right of it. If there is no element to the left or right, then the sum is considered to be 0. Okay, so this is the base case. So this is the formal definition of it. You don't see the AI because you can think of the chosen element to be a pivot, and whatever on its left, the sum of whatever is on its left is equal to the sum of whatever is on its right. Then you return yes, otherwise you return no. Just think of yes as number 1 and no as 0, since you haven't learned string yet. So yeah. So the problem, this is number of test cases. For now, we may not be interested in. So now I'm just gonna simplify the whole problem into if. Right. So I'm gonna. Okay. So I'm gonna simplify the problem like so. Given an array. If there is an element inside the array such that the sum of all the elements is left is equal to the sum to is right. So if yes, then return 1. Otherwise return 0. So here's an example. For example, if I give you an array of 1, 3, 4. Imagine this one is an array 1, 3, 5, maybe 2, 4, 5, 3, 1, and 2. Okay, so here is an array, and given this array as an input, the question asking if there is such an element inside this array. We do not really pay much attention to the position of the array. We just need to know that there exists an element such that whatever the sum on its left equal to the sum on its right. So as you can see here is that this number can be such an element. So if you can see on its left, so if the number 4 here is the element, I would denote by using a vertical stroke here. So whatever the number before that is 1, 3, 5 and 2, and whatever the number behind is 5, 3, 1 and 2. So you can see the sum of all the elements on its left, not including itself, will be this one will be 11, and the sum of what all the elements on its right is 11. So hopefully that is clear of the question requirement. So now is what I'm going to do next is I'm going to analyze it. How are we going to do such a thing? Right. How do we find such an element that fulfill this property? Well, one straightforward approach we can think of is that we just go through each and every element inside an array and checking for the sum of all the elements before it and all the elements after it is equal. And as soon as we meet such an element, we can conclude it. But if we go through the whole array and we cannot find such an element, then we can conclude that this array doesn't contain such an element, and hence we return 0. So now I'm write out the things that I need to do is the major things I need to do is find an element such that the sum of all the elements before it equal to the sum of all the elements after it. So to do that, what my pseudocode, before I go into the pseudocode, maybe the algorithm. This is just simple English word algorithm, doesn't have to be in the style of a pseudocode. Usually I do this because it's easier to think in English, and I don't have that constraint of the language. For example, the programming language, the constraint of the programming language, I don't have that. So I can easily express what I want to do. Otherwise, if I go straight into the pseudocode at this moment, I may get stuck. Why? Because sometimes the pseudocode have some constraint that I may not be able to think of. So to play safe, I just go into English words first. Alright, so what I'm gonna do is, starting from the first element, go one by one to the right, and every element that I choose, I will compute the sum of I will compute the following. I will compute one is the sum of elements before it, and 2 the sum of elements after it. Alright, so far so good. And compute. Okay, so now here you see this is a big. Alright, then the next one is if the sum 1 is equal to the sum 1, which means the sum of elements before the chosen element, equal to the sum 2, then return 1. Otherwise, continue to the next element. And if I finish the whole array without finding such an element, return 0. Right, so here is the whole algorithm. But the algorithm is not very detailed, in the sense that how do you find the sum of elements before it, and how do you find the sum of elements after it. And so this one you can break it into smaller problems. So this one you can break it, we can think of it as another problem, which is I call subproblem. Compute the sum of elements before an index I. Here is the first subproblem. Before an index I. How do you do that? So similarly, I just go an algorithm. starting from the first element, continuously add the elements until the index I minus 1. So this mean what it means is that if I'm given an array, I just go from the first element all the way until the I minus 1. So then it just a sum of elements inside an array, which is a very common usage of array. You can do that by using a for loop. Alright, so maybe this one. Right, so as you can see, this one is simple enough, so you can use one for loop and you can solve it. So the subproblem one is quite okay. Now there's another subproblem which is very similar, which is compute the sum of elements after an index I. So very similar algorithm. So here is the difference, maybe the starting point and the end point. So in the subproblem 1, we start from the first element and end the element just before the chosen index I. So in this case, we will start from the element at index I plus 1, because we don't want the element at index I, just want the one that's to immediately to its right, and go all the way into the end of the array. So from the I plus 1 element, continuously add the elements until the last element. Right, so over here you see that my screen changed, that means X is too long, so I just break it down. Right, very similar approach. This one maybe we can use a for loop, with just different starting and ending point. Now comparing the sum is quite simple. We can, so over here I'm talking about here, so at this point comparing the sum 1 and 2, you can use an if statement to do so, and otherwise you can just continue. So as you can see, the whole algorithm is like so, and the next steps I'm gonna do is to translate this algorithm in English word into pseudocode and eventually into C code. Okay. So if you have any question at this point, please feel free to post onto the live chat and I will address that question. Right, so now I'm just gonna give quite a number of space here. So okay, quite a number of space. Right now is pseudocode. So you can see my step of doing so is, whenever I reach a problem, I don't go straight away into coding. I do planning first. The very important one is to understand the questions. So if I don't understand the question, I cannot really think of a correct solution. So I have to make sure that I understand the problem correctly. In this case, lucky for me, the problem is quite straightforward. So then I move to the next step, is to define an algorithm how to solve the roughly kind of like the outline of my solution. And when I get all of them down, I'm thinking if it should be correct, in my opinion. Then I move on to writing pseudocode, how to do it. That's correct. So there's a question, is that say the first element you mean array 0? Yes, that's correct. So if you notice, there will be corner case. For example, what if the chosen array, the chosen element to be 0? Then what will happen? Well, according to the question, you can see over here, according to the question, they say if this okay, if there's no element to the left or right, then the sum considered to be 0. So this can be solved if we initialize the sum to be 0. So that's all good. Right, so now let's get back to the pseudocode. Probably I should start with a pseudocode of the easier problem, subproblem 1. Right, so pseudocode. I'm gonna give it some space. Right, so starting from the first element, so this one may be first. When you write a pseudocode, you should give it a name so that it's make it easier for you to translate it into C code later. So maybe you want to compute some before, and as always, when you want to compute an array, so in code you don't write array and then index. So you see in pseudocode you don't have the data type yet, or what you have is just words. In this way, if I want to make it more of an array, I can put a square bracket there. It's meant for you to understand. Anyway, so right, so when I come here, indent one level in. So now starting from the first element, continue to add the elements. So as you already know, when you add an element, you have to have some kind of sum variable to hold the value so far. Right, so I create a sum variable, assign 0, initialize 0 to it, and what I do next is I go a for loop. For now is index I equals 0. So when you write pseudocode, you can use up to, which means it's go up, and every time it's go up by one unit. So yep. In pseudocode, you may want to go at I equal to 1 because it's pseudocode. You can go 0 as well, but generally it's when you write pseudocode, it's 1 base array, and up to index -1 do right. So you just plus the sum of the array I and n4 and just return sum. That will probably do, and this one is n of the function. So here you can see it's directly translating, starting from the first element. So in an array, if you start as 1 is the first element, and continuously add all the elements until index I minus 1. So here's the index I minus 1, and you add the element, and you retrieve the value of element using this syntax, array and square bracket. I probably already know it, and similar add. Right. Very similarly for subproblem 2. On compute sum after. Right, similarly just initialize with sum. Right, for now the index is starting from I index +1 up to. So what's the next one? How do you retrieve it inside the pseudocode? You may want to press array or size. Yep, you can totally do that. But in the C code later, you will see that well, you will need a variable size whenever you pass in an array. Right. So similarly, array I and return sum. So the question you may ask now is that will this one work? Well, when you have a code out, but if you give it a few examples, you will see that it's work because it's simple enough that you can see it's work. Right. So now the next thing is to combine these two and come up with the main algorithm. So how do you go starting from the first element? You can use a for loop up to what's the last one? The last one will be array.size, so I haven't give it this one, so maybe check. The code is checked then. Array. So this check function will be explain the after code again. Right, the sum after. So let's say if I have an array of 1 2 3 4 5 and I chose the index to be 3, so which means hang on. So you can see from here now. Yeah, Clement is right. I'm breaking this down into two so that you can probably know the idea of how to sum between the array. This one definitely you can sum them all up and then do sum, and then whenever you move to one element to the right, you can adjust the sum accordingly. Yes, that is one of the faster way to doing it, but if I go straight into that solution, well, it may cause confusion actually. So I'm not sure if I should start doing that. But let's just go through the question from Drew first. Is that explain the code after. So let's say if I have array of 1 2 3 4 5 6, this is an array, you can imagine. Right, and now if I have index 3 to be chosen, so index 3, let's say if I start from index start from 1 1 2 3, so this one is the pivot element. Now I want to calculate all of the element on its right, sum after. So I'm going to calculate the 4 5 and 6. You can see that the starting point of it is index plus 1. So index plus 1 is index 3 plus 1 is 4, and it's go up to array.size. So in this case, this is a way of writing pseudocode. If you want to know the size of an array, just write that. I'm pretty sure people will understand, because yeah, just imagine that array.size could give you the size of the array, and in this case 6, so the index I will go from 4 5 6 and just plus the sum. Is that okay? Right, great. So turning back into this, check array. Yeah, since these two function is very similar, you can do array and then start and end index, and it will do the same things actually. Yeah, correct. So now is starting from this line, right, go one by one to the right. Yep, size -1 is correct, because if you are using the 0 base array. But in this case, since if you notice above, right, when we write pseudocode, we usually start the array index at 1. Not trying to confuse you, but yeah, definitely if you use the 0 base array, then at this point array.size will be -1. Yes, you are correct. So later when we translate this pseudocode into C language, yeah, we have to -1 at the array.size. Otherwise, you know what happens. Try go one up to right. Every element I choose, I will compute. So let's say sum before equal to compute sum before. I just pass in it the array, and I just pass in the index, which is I. And sum after, compute sum after. So as you can see that if we already have the function defined below, right, in this main function, it's very simple. You just make use of the function, and you can achieve what you want, right? So now what's the next thing? If the sum 1 is equal to sum 2, then return 1. Well, this is just a simple if sum before equal
because this is pseudocode, so I just put a symbol equal, but when I go into C, it will be equal, so don't be confused of that. After do return 1, right? And if so, in pseudocode, because there is no semicolon, so you may want to put those keywords, for example, and if, so that you know that is a block of code. You can imagine the do and the and if is just like the curly braces. Right. Okay, now, right, so based on the algorithm I'm done over here, and if I go through the whole loop without finding such an element, I can just return 0, and that's it for the function, for the main computation over here. So yeah, as you notice, right, in pseudocode, here is my mistakes. I should have write this to mean assignment. So instead of equal 1, so I write the arrow pointing to the things over here. So that one is assignment, not so that you are not confused with the logical comparison of equal. Right over here, yep. I made a few down here as well, I think, yeah. Thing like that, yeah. Okay, let's go to line 17, I guess. Yeah. Right, so we are back at the algorithm, and checking the pseudocode seems to be correct. So every time, now let's go back again. Every time I go from 1 to the last element, you can think of array.size to be the last element. Then I calculate the sum before, calculate the sum after, and if those two are equal, return 1. Right? Seems all good. Now let's go to the main meat, which is the code. Right, first of all, I'm gonna include standard ino because I'm gonna use it for printing. Now, do I need math library? No, at this point, because I don't use power, I don't use square root, so I don't include that. Right, next thing is the main function. Return 0. Okay. Well, if you do your lab here, probably you have some function commands like the header commands, explain your name, your discussion group, explain briefly what the problem does, but I think I will skip that for now. Right, now, sub problem here, computing sum before and compute sum after, if you want to combine them together, but I just want to show you one trick that you can do, is that if you see two codes that are very similar, you can combine them together, and with some general input you can make them work for any case. To illustrate that, let's say now instead of having that one function, right, I have this. So I have compute sum before, I need an array I need a size, and I need an index as well. Right, and let's say I have another one, which is compute sum in array to int size in index. You can check back the first half of the live screencast, and you can find the Vim shortcut. It's just part 1 of it. I'm gonna do another part 2 later, probably later, with more complicated maneuver, so you can apply that too. Alright, let's get back to this. So now, one thing I want to notice is that whenever you write a function prototype, you should have something below the main function to implement it. So what I'm gonna do is I'm gonna yank 2 lines, and I'm gonna paste it down here, so don't have to repeat that. Right, and one trick that I'm gonna show in the Vim tutorial part 2 is that you can do repetition of the command. For example, in this case, I want to go to the end of the line, delete this one, open braces, go braces, like that. I don't want to repeat the whole thing for this one, so I'm just go by pressing the full stop command and just automatically repeat the whatever the sequence of commands that I used before that, and just apply. So it will be faster if you want to do it that way. Right, so before I go into implement that, I'm gonna do the function commands. So this one will compute the sum of all the elements in the given array up to element just before index. Right, same things. I'm just gonna put some placeholder for the function below here, so that I don't forget to write function commands which contribute to the start point. Right, just translate the code from above. Let's go up to above. Right, just right, sum equal right key. So put that in sum equals 0 for now. For the for loop, you can write this, and I less than index, because I don't want to include the index, so I can use a less than index, I plus plus to increase that. Right, and sum plus equal, well, this one is a shorthand for sum equal to sum plus something, so you can do that. Array I. So over here there's a few things, is that there's a precondition. A precondition in this case is that the index is less than the size minus 1. Otherwise you will try to exceed the element outside there, and as well as this one has to be less than or equal to index. Right, everything is good. This one is equal, yeah. So this is a precondition. Size minus 1, that means is the last element of the array, and return sum. Similarly for this one is in sum equals 0 in I, so that you can traverse the array I equal to. So at this point, well, the same preconditions over here, so I'm just gonna yank that. I'm gonna paste over here. Right, same condition. I equal to now is what, index plus 1, because we don't want that index, but we want the one that next to it. And now we go all the way into the size. So in this case you can use less than size, which means it's equal to size minus 1. Right, just now you mentioned that. Right, and same thing, plus equal array I, and return sum. So here is the point I want to make, is that you can see that the structure of these two are extremely similar, and the difference is only where at the starting of the array and the ending of the array. The ending of this is one is just one before the index, and this one the starting is one after the index and just before just the last element. So we can combine these two together with another one, compute sum, and definitely we need an array. We may need the size, we need the index, and we need the start and the end. So we don't need the index anymore, because this one we can specify it during when we use the function. Right, so same structure. So if, for example, if this one have the same structure, I'm just gonna V to put you in visual mode, highlight everything, yank them, and paste them. So that's how you copy and paste inside here. And where do you define index? Which index you right, there's a question of don't think you need the size, right? Yeah, you may not need the size, but that's given that the endpoint, the end you are given here is correct. So yeah, definitely you can do that. You can overput there, and you have, but then you have to have this precondition, is that first of all, start must be less than or equal to n, and the second precondition is n must be less than size, right? Oh yeah, so just recognize that I do not really need that index. Why? Because let for example, if I want to compute the sum before index, let's say I have this array, alright, and I want to compute the sum before index 3, which the index 3, let's say, is this number, because we are thinking in C, right? So index 3 is this number 4, so I want to compute the number from 1 2 3 but not 4. What I'm gonna do is that I'm gonna call this compute sum, pass in the array. The starting point will be 0 because I want to start from the first one, and I want to end is at 3 minus 1. So here I'm thinking of I will go until the end, so this one is inclusive, so you can do so. Or if you don't want inclusive, maybe you want to pass in directly the index 3. That is up to your implementation below here, which I'm going just about now. So if here you put it as less than without the equal size, it will be not inclusive. But if so, this one will be the correct usage of it. No, this one would not be the correct usage. This one will be the correct usage of it, because index 3 at this point, so it's less than n, which means it will stop here. It will stop at number 3 here. So it depends on your implementation. So in this case, I do not want to be, I want to be inclusive. So that means this one has to be minus 1. So I want to be inclusive here, right? Because n, so just stop. Yeah. It's all depends on your implementation. So here you just make this whole function general by substitute some of the things, some of the parameter, and yes, that's correct. So over here I'm just gonna comment them all out. What I'm gonna do is maybe so I'm just comment that, just comment this out as well. We're just gonna use the general function then. Okay, so now here we have this, and we haven't defined the function prototype, so we're just gonna go back up. Wow, this is a whole lot of commands. So alright, so we just go back up and replace this with this one. So we don't need this, we don't need this, right? And we're gonna replace this with semicolon. Okay, so now we can do another one, which is to check. This is the function check we defined just now in our pseudocode, and it just needs an array. And actually, do we need the size? Yeah, we need the size, because for example, if you want to compute the later half of it, you may put the size as an input when you use the function above here, right? Same thing, I just want to go to the end of the file by pressing Shift G. So I'm just gonna paste the thing over here, right? Redefine it, and now okay, so now how do we check it? We might jump back to our algorithm. Probably I want to yank this whole thing here. No, I want to yank the pseudocode so that it's easier. So I want to yank here. I'm just gonna paste here. Alright, so here is my function, and here the above is the pseudocode. Right, for in I, so I need an I. For I equal to the starting point of the array and up to array of size. So this is less than size. And next one. Now we need a sum before and sum after, so I'm going to define this. Sum before and sum after. You may or may not want to assign it to be 0, but anyway. So now sum before equal to compute sum, and I'm just gonna pass in the array. Here's the way you pass in the array. You do not need the square bracket anymore, right? And what's the signature of it is the start and the end. So the starting is always 0 if you want to calculate from the left, and what is the stopping one of it is the I minus 1, because it is not it's inclusive, so you don't want that. You want to stop right before the I minus 1. Right, and similarly sum after equal compute sum array, and now where is the starting point? The starting point should be I plus 1, and what's the end of it is size minus 1. Right, so I want to stop at the last element of the array, which is at the index size minus 1. Okay, and do a simple computation. Sum before equal sum after, and just gonna return 1 if it does, and so and if n4, and now it just returns 0 if it doesn't. Alright, so here's the whole code of the check function. Will it work? Well, let's try it out. We have to test it. So before we test that big function, because this function, right, it uses a compute sum, so it only makes sense if we check the compute sum and make sure it's correct first. Otherwise, what if this one is wrong? So this one probably wrong as well. So let's go to the main function, and we're gonna do some incremental testing. Alright, let's define our array. So let's say my array. So here's one of the way to define the array: 5, 3, 2, 1, 4, 2, 5, 3. Alright, is a initialize the array with that. Okay, and I want to compute sum of this array. The size, I don't need the size. I want to start from 0, so I want to stop here. Alright, hang on, let me put some comment here. So this one, the index is 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Right, so here's the index. Okay, so now I want to compute the sum before the 4, so I'm gonna put 4 minus 1. So this means I'm computing the 5, 3, 2, and 1, 2, this one. And if I want to print that, I want to printf this sum before index 4. Okay, so if we compute from starting from 0 until this index, which is 3, so we compute that, and the expected output should be 11th. Right, so let's compile it. This one is Sherlock. Hang on, I haven't saved it. Right, so I'm save it. You can use external command. This one will be in the Vim part 2, which is some of the advanced command that you can use in Vim. Right, so you can directly do this without going to the terminal. Remember, with all, I want to output Sherlock, and I want to straight away use it. Let's compile first. Right, no warning, good. And now I want to run it. Sherlock. Right, sum before index is 11. Seems to be working. Okay, great. Now let's check sum after it, which is by our computation, will be starting from 4 plus 1 until the size. So in this case, the size is equal to 9. Alright. So in this case, size is equal to 9. And same thing, it should return us. So I've just saved it, I recompiled it. No warning, great. Right, we're gonna run it. Sum before index. Right, so something happened here is that size is 9. Oh, alright, so it had to be size minus 1 because it's inclusive. Yep, that's correct, thank you. Right, great. Now everything checked out. Seems that our compute sum is simple enough, and it seems to be correct. Now let's go for the big moment, is that we have to go for check. So printf the array pass. So if it's passed, it will return 1. If not, then just return that. So just gonna pass in the array, and why do I erase the size? Right, and size. Right, no warning, good start, and the array passed. So now let's add a few more like this and see whether it's passed. My projection is that it will not pass, so let's check it out. Let's recompile that, run that. Why is it still passed? So is there any sum that let's say if we have this 5, 5, 10, the left one will be 15, this one will be 13, so it should not be. So here we see that we have the wrong output. So how we're gonna tackle this is that we're gonna check. Let's say if alright, so I recognize the problem is that my size over here is not corresponding to the big size over here. So because I just add a new element but I haven't changed my size, so what it does, it only check the array until this element. So if we change to 10, save it, recompile it, and run it. So the array doesn't pass because there is no such element such that the sum to its left, the sum to its right is correct. So right, the problem is solved. The question is, can we do better? You see that every time we let's go to the check. So to go fast check, you can use a search function. This one will also be mentioned in the next Vim. Right, so I go to the check function and just search it. Right, so over here you can see that every time we move the I, right, we just recompute the whole sum over and over again. What I mean is that, for example, if you look at this example, if I have 5, 3, 2, 4, 1, and now 3, 2, 4, 5, so you can see that whenever the I, right, it goes to a new index, it's just recompute everything on the left and recompute everything on the right. But do you think that we should do that much work? No. The thing is about it is that when you move to the next one, you can just use whatever the sum on the left have already plus the thing that you just moved away from, and you take away whatever the numbers contain from the current element 2 over here from the right sum. What do I mean? Right, let's say that now the index. Alright, I'm gonna put index here on top of it so you can see easier. Right, so now let's say my current index is 3, so that means that my sum before will be what? Sum before will be 5 plus 3 plus 2 was 10, and sum after will be equal to 1 plus 3 is 4, 6, 10, 15. Alright, so here is my current one. But now if I move the index to number 4, which means my the pivot element moves to the next one, you can see that the sum is just whatever before that, whatever before this, plus the one that you just move away from. And this one is the previous sum, and you just take away the new one that you just use as a pivot. So there's certainly a way of faster doing that. Alright, so now how do we modify this to be more efficient? Right, I think I'm gonna do a quick one here. Is that I just keep the sum before and the sum after. So to do that, I have to assign to equal 0. Doing this is not very nice, so I'm just gonna break it down, do like this. Right, sum before and sum after. Okay, and now every time we go here, instead of compute sum, which will redo it, the whole thing, I just take the sum before 2i. Right, so when I is equal to 0, the sum before will be nothing. So plus array I minus 1. So here's a dangerous thing is I minus 1, but we start from I equal to 0. So I'll fix that later. So let's get the logic out first. This one will be minus. So hang on, before we go into that, we have to initialize the sum. So first of all, when the index start at 0, the sum on the left is 0, but the sum on the right is all the way up until here, from the whole thing here. So before that, the sum after over here, I have to give it some different value. To do that, just go I equal to 1, I less than size, and I plus plus, and sum after plus equal to array I. Okay, so what does it mean is that it just go all the way starting from index 1, which is this one, starting from index 1 all the way into the size minus 1, right, the last index. So initially, let's trace it. Index is 0, this one should be 0, and this one should be, wow, I shouldn't do that. Right, this one is 5, 9, 10, 15, 20, 24, right? Okay, so sum after should be 24. Now is the main thing is that we have to go through this whole loop, this whole for thing, right? And right, starting at 0, so we check if so is sum before equal to sum before. So just now the observation that we have is that whenever the index have somewhere here, and let's say is the currently one is this one, and when it's moved to the next one, the sum before, which is this one, will plus the previous element that we move away from, right? So that means it have to plus and equal to the I minus, no, not this one, why I minus 1 is that because when we move to the next one, this means when it go to the new iteration, move to the next one, then we just take the previous one, the one before it. So let's say this one is the current iteration and the previous one is I minus 1. Right, but we do have to do a simple check before that. So this one is only applicable when we want to do I equal to it's not 0. That's correct. Otherwise we will have some problem. Alright, and indent that, do that, delete this. Okay. Alright, how about sum after? Right, since we do not start from this one, so the sum after, we start from here, the sum after is here originally, we do not do any changes, but if it moves to here, what do? We change it. So we minus the current one, so that means sum after minus equal to array current one. Right, one thing to know is that if you want to minus the current one, then this one have to start from 0. Take the whole things. So for this algorithm to work, this have to be the sum. Originally sum after is everything here, but then when it's going to the first iteration, it have to minus the first one. It have to take it out, and then now we see that if it's equal, then we return 1, otherwise return 0. Alright, seems to be okay. Let's check for the result. So we do not touch anything from the printf because basically they're just the same thing. We just changed the algorithm we use inside it. So let's recompile it. Right, no warning, great start. This one 0, which is correct. If we take out the last one, it should return us 1. I'm gonna save it, recompile it, and run it. Okay, good. So our new algorithm works, which checked out. We test that. You may want to give more, for example, more corner case. So What I mean by corner case is, for example, one element with handle is correctly, by right it should. So let's check that. That is one of the corner case. So see corner one, and check this. Just gonna comment this out. I don't want that. Alright, check, and I want to check the corner array and sign and just directly put 1. Right. Just save that. We compiled it. Right, warning, unused. Okay, unused. Yeah, because we just just to take out the warning and just put there. No warning. Restart. Okay, array pass. Right, great. Seems to be correct. So, yep, here is the example. And if you want to try that with a sample input in here, certainly you can do so. So I get this one is the end of my session for today. For any question, do you have any ideas when our PE1? No, that one I have not. I haven't not received any information about that. Right, any other questions? If not, then you can subscribe to this one. So I usually do this session from 8 to 10 every Sunday, and if you have any burning question or any hard problem that you want me to go through, see my thought process and algorithm designing, feel free to drop me an email, and I'll do my best to address that in the next session. Okay, so peace out.